Hi, my name is Tom Cooper, and I'm a postdoc at Carnegie Observatories. I'm going to talk about why galaxies are different shapes and colors. Behind me are examples of the two main classes of galaxies, spiral galaxies to my left and elliptical galaxies to my right. In the spiral galaxies, you can see bright cores and swirling lines around them, which we call spiral arms. The spiral galaxy at the top is Andromeda, our nearest neighbor. It seems a tilt, which shows us that it's pretty flat, so we often talk about these galaxies as having disks. Our own galaxy, the Milky Way, is also a spiral galaxy, and our solar system is in one of the spiral arms. The elliptical galaxies also have cores, but beyond that, they look more like a squished down sphere or a football shape. Ellipticals are also a little bit larger and more massive than spiral galaxies. Spiral galaxies are bluer than the ellipticals, especially their arms, which is a big clue. Most of what we see in galaxy pictures is light coming from stars in the galaxies. It turns out that the stars which shine the brightest also burn out the quickest, and these bright stars are blue. Redder stars last much longer, but they're way less bright. What that means is that galaxies that are blue must have lots of stars that formed recently, while red galaxies are made up of older stars. So, spiral galaxies are typically forming stars at a higher rate, which makes them bluer. The shapes of galaxies are all about where the stars are, and the star's motion is based on gravity. Stars orbit around the mass in their galaxies, similar to how the Earth orbits the Sun. In a spiral galaxy, the stars are all circling around in what is pretty close to a two-dimensional plane, while the stars in ellipticals have orbits with more randomized orientations. So how do galaxies get this way? Galaxies start out as these spinning blobs, and they grow by gaining mass and combining with other galaxies. While this is happening, the spinning causes them to flatten out into a disk. The flattening is a little bit like dough being tossed up and spun to make a pizza. Elliptical galaxies form from mergers between two spiral galaxies that have a similar mass to one another. The Milky Way, for example, is going to merge with Andromeda, and that's likely to result in an elliptical galaxy. But that won't happen for 4.5 billion years, so we don't need to be worried about it. Not all mergers turn spirals into ellipticals, though. Peculiar galaxies, another main classification, are actually two or more galaxies colliding or interacting. There's also a category of irregular galaxies, which is sort of a catch-all phrase where we put all the galaxies that don't fit in the other classifications. Galaxies offer a lot more to learn about than just their shapes and colors, but these classifications are useful to give a quick idea of some properties a galaxy might have.